Good afternoon, everyone. This is Professor Lewis, and today we're going to focus on recursion and factorials. Okay, as you can see, I am sharing my screen here, and we're going to cover how to use the factorial algorithm with the recursion technique. Okay, and this will cover highlight module 11. All right, so there are four main concepts that I would like to focus on in this particular lesson. Um, the first concept is what is recursion and how it works, what is a call stack and what its purpose is, how the factorial algorithm works. And then we'll take a look at how to code factorial algorithm using recursion. All right, so just for a few definitions here, right? And I know that your textbook has covered some of this in detail, but I'll just kind of recap some of the terms as well. So recursion itself is primarily a technique that is used when a function calls itself to solve a smaller part of a problem until it reaches a base case that stops the process. Recursion uses what is known as LIFO, right? Last in, first out. Okay, by pushing method calls onto a call stack located in memory. Okay, so then what is a call stack? A call stack is basically, it's a technique that implements last in, first out, also a LIFO, right? And pushing onto the stack basically means adding a new function call to a stack that the program uses to remember where to return and what local variables and arguments belong to that particular call. Okay, so it's important because it preserves each call's state. So what it does, it enables recursion to work correctly, and it lets the program resume at the right place where functions finish, which is known as unwinding the stack. Okay. So what is factorial, right? So that's basically recursion, right? Recursion is just basically a technique where a function is essentially calling itself until it reaches this base case, and the base case says to stop the recursion calls. Okay, so we're going to take a look at how recursion works with the factorial algorithm. Okay, and when recursion is actually implementing these recursive calls over and over again, each of those calls are stored on top of what is known as a stack, right? For the last in is the first one out. It's very similar to when you're stacking poker chips, right? When you want to use one of those poker chips, you pull from the top of the stack, right? And you continue to pull from the top of the stack until you reach the very last chip at the bottom. Well, recursion implements call stacking the exact same way. And what we're referring to when we say call stacking is methods are being placed on top of a stack. They're stacked on top of each other in memory. All right. And recursion, once it stacks them, it goes back and it unwinds them by reading each method starting from the top one by one. So the very last method that's pushed onto the stack is the first method that is pulled from the stack or popped from the stack. Okay, hence last in, first out. So we're going to look at the factorial algorithm, right, and how it works. So what is it? It's an algorithm that can use this recursive technique, right? It is the product of a number and all the positive whole numbers less than it, right? Numbers from 1 up to n. It's also defined by the factorial of 0 equaling 1. Right, so factorials are commonly used in cases such as when we want to compute probabilities, or we want to use it in statistics, calculate permutations, and various types of combinations. All right, so the formula that we're going to use is quite simple. We're going to do 4 factorial, and it's written as 4 bang or 4 exclamation mark, right? And we're essentially using multiplying 4 numbers uh, against each other. 4 times 3 times 2 times 1, which will give us 24. All right, so this is part of our program, a snippet of our program that we're going to use. So it evaluates to check. So we're going to pass in a number value, 4, right, into our factorial function. And it first evaluates to check if the number is equal to 0, right? If the number is equal to 0, it will return the number 1, all right? Hence, our definition of factorial 0 is equal to 1 here, right? So if the number is equal to 0, it will return 1. Otherwise, it will recursively call our factorial function, right? That will subtract 1 from our number that we're passing into our function. It then multiplies the result by the number that we passed in, right? And we'll take a look to see exactly how this is done, when this multiplication is actually implemented, okay? Python also evaluates the right-hand side, right, before assigning the result, the value to the result variable, right? So whatever the result is, whatever the calculation here is, and whatever the result is, right, it will implement the right side first and then store the results, of course, on our left-hand side into our result variable. Okay, so the product is then stored inside of this result variable. Simple enough. And this is what I've listed here. These 3 items, or 4 items. All right, so pushing calls down the stack. All right, so we're going to take a look at exactly how, and eventually we'll look very shortly at how we implement this in code as well. So when you first call factorial, our function, factorial, right, we're going to pass in the number 4 as our example, the example that I showed here. All right, so we're going to pass in the number 4. So it's 4 factorial. All right, so that means we'll be working with 4 numbers, 1, 2, 3, and 4, or 4, 3, 2, and 1. All right, so what Python does, it will push these method calls onto this call stack, right, until the base case is equal to 0, okay, or until this value, num, right, from this recursive call, a factorial, is equal to 0. All right, so this is our base case, and our base case tells the recursive call when to stop, okay? Or when to stop recursively calling itself. All right, so if we pass in our n value 4, all right, so let's say that this is our factorial function. We pass in the number 4, all right, simple enough. So our num variable, our n value, will be 4, and our factorial, our value inside of our factorial function, becomes 4 minus 1, which will give us 3. All right, so if we go back and take a look at the actual expression here, all right, we're passing in the number 4 into our function. For a num, 4 minus 1 will give us 3. So that will leave us with factorial 3 here. Okay. So we're going to push this onto, sorry about that. we're going to push this onto the stack. All right, this is our first call, our first recursive call. So now, recursively, we're going to call factorial again, but this time with our n value as 3. So we pass in the number 3. So now our n value, num value, is 3 multiplied by factorial, 3 minus 1. So now the factorial value is 2. All right, so we're going to recursively call our factorial function and pass in the number 2. So our n value is 2. 2 minus 1 gives us 1. When we pass in the value 1, recursively, we're calling factorial, passing in our new value, which is 1. So 1 multiplied by our new factorial value, 1 minus 1, which gives us 0. So we pass in 0 into our function, right? So now we're passing 0 into our function. So what does that do for us? It will tell us, right, during our validation and our check, if that num value is equal to 0, which it is, then we're simply going to return the number 1. And that's what we're returning there. Okay? So we're setting factorial 0 to 1. Okay, so now that we have our stack, we have all of our recursive calls that are just sitting in memory in a stack, all right? So what do we need to do? So what recursion does, it will unwind the stack, or basically pop off every method starting from the top, just like our poker chips. Starting from the top, it will take each method one by one. Okay. So what does that do? So when it unwinds the call stack, Python interpreter unwinds the stack and then multiplies, right, the n value. So the multiplication can then finally happen. All right, so we can think of this as computing on the way back up, if you will. So we have pushed 4, 3, 2, 1, and 0 onto our stack. All right, so 0 or 1 would be our top method, then number 2, then number 3, and then number 4, and so forth. Okay, so when we unwind, each call uses the following, and this is important: the returned calculated factorial value in memory from the previous recursive call. Okay. So when Python interpreter unwinds the stack, right, the returned calculated factorial value that's in memory, right, from the previous recursive call, right, we're going to use that, and then we're going to multiply it by its saved n value. The n value that we entered when we initially started our recursive calls, 4, and then 3, and then 2, and then 1, and then 0. Okay. So let's take a look at how it will unwind the stack, right? Or pull from the top of the stack each method call at a time. So this is how the recursive technique works, or the recursion technique works. So here, this is our saved n value, right? Our saved n value plus or multiplied by our given base case value, which is the number 1. All right, so we multiply 1 times 1, and that returns 1, or the result is 1. Okay. Our next, so we're unwinding. Our next n value is 2 multiplied by the previous recursion call result, which is factorial 1, right? Those are previous factorial, I'm sorry, our previous recursion call result, right? Which is 1. So 1, I can get this right here, 1 multiplied by 2, all right? Here we are. Our 2 multiplied by 1, which gives us 2. So it returns 2. Okay. Our next n value is 3. Okay. It is multiplied by the previous recursion call result. All right. Our previous recursion call result is 2. All right. So, which is here. So 3 multiplied by 2 gives us 6. So it returns 6. Right? And then finally, our n value is 4 multiplied by the previous recursion call result, which is 6. So we have 4 multiplied by 6, which gives us 24. And it returns the results of 24. Okay. So the key here is that we're using our n values and we're multiplying them by the previous recursion call result. All right, 2 multiplied by 1, which gives us 2. Our next value, n value, would be 3. Its previous recursion call result is 2. 3 multiplied by 2 gives us 6. It returns 6. Our last n value is 4 multiplied by the previous recursion result, which is 6. 4 multiplied by 6 gives us 24, and it returns 24. Okay. All right, so let's take a look to see how we do this in Python. All right. And so the key thing is that whenever we are using recursion, it will recursively call its function until it reaches its base case. And the base case tells it to stop the recursive calls. Once it gets to that stopping point, it will unwind every method call that is on our stack starting from the very top. All right, and then it works its way down until it reaches the very last call. All right, so let's build out a very simple program that does this recursive calling to implement our factorial algorithm. All right, so the very first thing I'll do is to create a simple function. I'll call it main. All right, and I'll just have the user enter a number. Enter a non-negative number. Okay, so we'll have our user enter a non-negative integer. Okay. And then we will Oh, I don't want to use the factorial, so I'll just call it fact. How about that? Okay. We're going to create our own factorial method. Okay. So here we're going to get the factorial number, right? This is where we're going to initiate the recursion call, okay, inside of our main. And then finally, when our number 24 is returned, we'll just simply display, right, the actual number in value and the actual factorial. Let's say something like the factorial. Uh, All right, so we'll display the number, the in value, right, for each factorial, for each number that is being calculated inside of our factorial function, and then the factorial value itself. Okay. All right, so let's create a simple function, factorial function. And what this function will do, it will use recursion to calculate the factorial of the argument that we're going to pass into it. And the argument that we're going to pass into it is number 4, right? And as we stated, it must be a non-negative number. So we'll call our function factorial. We'll provide a parameter for it. So we're going to pass in our number 4. So we're going to first check to see if our num is equal to 0. Why? If it is equal to 0, we will return the number 1. Or else, type it in. Factorial num minus 1. So we're creating our own factorial function. Okay. So here, this is where we're going to pass in the number 4. Our number 4, right, will be num. We will subtract 1 from 4, right? And that will be our very first factorial value. When we unwind, we will multiply, right, that previous value that was calculated for 3, right, multiplied by our num value. Okay. So then, so that we can actually see what it is we're calculating here. I'll just type in unwinding. Factorial equals the results. Then we'll return the result back to our calling line, which will be the factorial on line number 7 inside of our main. So here, what I'm essentially doing, I'm displaying the actual in value that we're unwinding, the factorial number, the factorial that we're going to be multiplying it by, and then what the result is. Okay, so we can actually see, so let me pull this back up again here. So we can see it as it is doing its calculation. We can actually walk through it line per line. Let me move this over here. Okay, so essentially we're going to call, right, our factorial function by passing in the number 4, and we'll do our calculation, and it will store, hold this in memory, factorial 3 in 4, factorial 2 in 3, factorial 1 in 2, factorial 0 in 1. Okay. All right, so what I am going to do, I want to show you what it looks like in real time. So instead of just, I'll run it first so that you can see that the calculation is 24. Then we're going to debug it so that you can actually see as the values change as it walks through the actual code. So first I'll just run it for you. Run it again. Oh, I guess I need to add my main. That helps just a little bit. All right, so let me go ahead and just add my main here. All right, so when I run this, right, and I will pass in the number 4, all right, when prompt, and our calculation will be 24. Our factorial value will be 24. So when I click on run current file, it's going to prompt me to enter a non-negative integer. Okay. And as you could see, this is what the output will look like. All right, so I'm unwinding 1. All right, as we could see here. Let's go back. So it's unwinding 1, factorial 0. I left my parentheses off there. Add another parentheses. Give me just a moment. Let's go back and add that. Makes sense. So let's run it again. Enter 4. There we are. All right, so factorial 0, right, which is 1. So 1 times 1 is going to give us 1. Okay, so 1, the result of the previous call, previous recursion result, all right, factorial 1. All right, so that's going to give us 1. Here we are. 1, 2 times 1, which gives us 2. All right, the previous recursion call result, 2. All right, 2 times 3, 3 times 2, which will give us 6. And there we have 6. Previous recursion result gives us 6. 6 times 4 gives us 24. All right, but let's delve just a little bit deeper into this. Let's see what this really looks like underneath the hood. What is it really doing? So I'm going to debug it. And the way that you debug a program is by choosing breakpoints. So I want it to break at certain lines of this factorial function. So the way you do that, if you notice this little red circle, I just click once there. All right, this will tell the compiler or the interpreter to stop so that we can see what the value is inside of num, inside of this parameter. But I also stop it here, break it there. So when I'm running this program, you'll see shortly, we can see where it's evaluating that number that we passed in against 0. Okay. We'll do the same here so we can see what the results and what the factorial values are inside of our recursive function here. Okay. So I'm going to break on all of these. So this is how you're able to debug your program so that you're able to see what the variables are, what the values are inside of your variables as the program is running, as it's executing. Okay. So you select your breakpoints just by clicking on that number line. All right. And your colors may be different, but mine's are red. All right, so, and instead of selecting the run arrow, I'm going to select the little bug, the debug bug. All right, so when I click on that, I get a different screen, okay? Different types of consoles below. My console is prompting me to enter a non-negative integer, so I'll enter 4. All right, but more importantly, we want to see what the variables will contain, right, as we walk through our program. Okay, so it is connected. So it's waiting for me to press enter here. So I'll go ahead and press enter. I've typed in number 4. I press enter. So if you notice, it stops on our very first breakpoint, right here at our function definition. All right, so I want to see what the value of num is, and it tells us here, number is number 4. The value that's stored in this variable num is 4. If you notice also here, it shows you, this is what our call stack looks like here on the left side where it says main thread. This is our call stack. If you notice, the main method here has invoked or called the starts the program, and it invokes our recursive factorial function. So when I click on that, right, if you notice to the far right here, it shows that the num parameter now contains an integer 4. So this is a great way when you're debugging your program, you're able to see exactly what values are being stored inside of each variable. Okay. So the way that we're going to, if you notice here, we have a series of buttons here. The button that we're going to use is called step over. And what that does, it allows me to step over each individual line of code inside of my function. Okay, so my very first value for num is 4 because that's what I entered in my console here. All right, so when I click step over, watch what it does. It moves to the next breakpoint. All right, so here we're checking to see if the num, number 4, is equal to 0. And of course it's not. So it will exit out of this if true branch, right? And it will transition to our else branch. All right, so when I click step over again, all right, if you notice, so now it's showing us that the num in our factorial call is 4. So we're going to subtract 1 minus 4, right? And that will give us 3. But if you notice here, the num is still 4, right? And that is simply because recursion will not implement this calculation, and there's no result inside of our result variable. It will implement this calculation, this multiplication here, when we unwind, right? When we pull from the call stack, from the top. So now this recursion function here is going to call itself again with the number 3, and you'll see that very shortly. So I'm going to do a step over again. All right, and if you notice here, look at our call stack. Our call stack shows, if I select the very first, the bottom method that was called, it shows number 4. The next method that's called, factorial recursive call, shows the value 3. So if you notice here, we're passing the number 3 into our factorial function now. Okay. All right, so when I step over again, it's going to check to see if number 3 is equal to 0. It's not, so it transitions to our else branch. All right, so now we have number 3 inside of our recursive factorial function. We subtract 1 from 3. Okay, still we have no result. Why? Because it will not do the calculation, multiplication, until we unwind. And why? Because recursive calls will continue this recursive call until this base case, right? Until num is equal to 0. Okay, so that's when it will stop. Okay. So we have 4 on the bottom, we have 3. So when I click step over again, so if you notice, it's going directly back to the function call or the name of the function because we're continuously calling it, all right, recursively because we haven't met this condition yet. So if you notice now on our call stack, we have 4, 3, and 2, right? And it shows us this here, that num inside of our function definition is now set to 2. So when I step over again, is 2 equal to 0? No. So we transition to our else statement. Okay. And we subtract 1 from 2. Okay. We still have no results. Okay. So if you notice, when I hover over these variables here, it gives me a value if a value is there, right? It will give me a value, num is equal to 1. So if you notice, when I hover over result, there is no value that appears. That is because it has not completed the expression on the right side. Why? Because we are recursively calling factorial until we meet this condition here. Okay, so now we have on our stack 4, 3, 2, and 1. All right, so we click on step over again. Is 1 equal to 0? No. So we transition to our else branch. Okay, 1 minus 1 gives us 0. And what do we say the factorial of 0 is? Is 1, right? So we're going to click on that again. So this time we have 4, 3, 2, 1, and 0. Right? Our n values are 4 through 0 on our call stack. Right? Our parameter now shows that the num is 0. So what do you think will happen? We're going to click step over, right? And num now equals 0, right? It shows us this here. Num is equal to 0. So what does that mean? That means instead of transitioning to our else branch, what will it do? It's going to return 1. Because this is true now. So it's going to return 1, all right? And watch what happens when we return 1. We no longer invoke, all right? So here we're going to pass in our num. So now we're going back down the stack, all right? So now we're unwinding the stack, all right? So as we unwind the stack, watch what happens. Get our result there. So now we're unwinding the stack. We've returned 1. So let's move this over here so we can actually see. Okay. So if you notice, it returned 1. So factorial 0 is equal to 1. So 1 multiplied by 1 will give us 1. So the result here is 1. And this is our 1 multiplied by 1, which gives us 1. Okay, so that is our result. So when I step over again, now we have a result, which is 1. So if I look at my console, right, it will show me that result. Factorial 0 multiplied by our n value 1 gives us 1. Okay. And that's the console portion. So we step back into our variables to see exactly what happens next. Well, let's take a look. Let's follow it through. Okay, so if you notice, we're no longer calling our factorial, right? So we're actually simply unwinding our stack. So now the number is 2. So when the number is 2, right, as we notice here, our number is 2. We're going to multiply that by the previous recursion call result, which was the number 1. All right, so when we step over it, sorry, the result is going to be 2. All right, our number is 2, the result is 2. Okay, so when we take a look at our factorial, so the previous recursion call result is the number 1. All right, multiply by 2, our n value, and we get 2. Okay. We step over again. Let's go back and let's look. Our num value is now 3. Okay. So our num value will be multiplied by the previous recursive call result, which is 2. All right, so we can look at it here as well, which is 2. Okay. So when we step over, okay, our result will be 6. The num value, n value is 3, multiplied by the previous recursion call result 2, which gives us 6. And we can see that in our output. Okay, there's our previous recursion call result 2, multiplied by 3, which gives us 6. Okay. So if we step over again, our num is now 4. So look at what we're doing. We're unwinding the stack. So we're finally reaching, if you notice, our stack is shorter, right? We're on the very last call that was on our stack, right? Which is the number 4, which is the number 4 here, as you could see. All right, so it will be 4 multiplied by the previous recursion call result, which was 6. All right, go back here and look at it as well, which is 6. All right, so 6 times 4 gives us 24. So the result is 24. Okay, we step over again. Okay. And there's our 4, in value 4 multiplied by the previous recursion call result, which gives us 24. Okay. All right, and if we continue stepping over, all right, number 4, and it will give us our results. Okay. Factorial of 4 is 24. Okay. So the key thing here is the recursion, right? I just use factorial because factorial, you can also use the Fibonacci. You can also use the range of a list. I believe the textbook also goes into those different algorithms that you can use with recursion. The greatest common denominator as well you can use with recursion. But the goal here is to make the numeric value smaller, right? And the recursion component technique is used again when it calls itself, right? And is trying to solve a smaller part of the problem, right? So we're narrowing it down to a smaller part of the actual problem, of the actual scenario that we were working with here. Okay, and using debug, I like using debug because you're able to actually see the values in the variables as you step over each line of code, right? Hopefully that helped you all kind of get a better understanding of how recursion works with factorials. If you have any further questions, please feel free to send me an email. I was going to say give me a call. No, don't give me a call, but send me an email or post something on the discussion board, and I will gladly answer your questions. All right, thank you all for listening, and everyone have a wonderful evening.